Welcome to Matherdays. Math's so fun. We do it on Saturdays. So glad you're here. Right now we've got a small group. Let's see how many other folks join us. But either way, I love small groups, large groups. We will make the best of it. And the best part is I think that this lesson is already like together to give to students almost right away. So you'll be able to leave with something that you can use in your class. So on side 4 and 5, usually we start out with kind of sharing successes and celebrations. So go ahead and add yours there. And Raha, my daughter is obsessed with Squishmallows also. What one is that? And do you have a collection?
I do have a collection, unfortunately, a 32-year-old with a really growing collection. Currently, I'm looking for any type of dragons, but recently I bought a narwhal. This student has a little like cat Dracula, which is so cute. And I have a couple of squishmallows in my classroom that the kids like to touch and just building community. And your daughter is welcome in my classroom anytime.
Oh, thanks. Yeah, she loves those. You know what's a really fun one to do with them is if your kids are learning about weight, they're one of the weird ones that don't weigh nearly as much as you like if you've never touched one, I should say. If you're not familiar with them, they are first of all the softest, squishiest things like ever. But it's always fun to like bring their stuffed animals in the math class with weight and all that. Cool. Um, Zoom update. I put the whole Zoom thing in there because I think that's probably the case for some other folks. The one that I'm sharing on here. So you all probably know I'm a big board game geek. My family doesn't really do family dinners because I work in the evening starting at 4:30 and just it's mostly just leftovers. We do family breakfast is a bigger deal. And so almost every morning we play some kind of a board game together. And this last week I was very excited because my kids ganged up against me, but they totally used their logic to put this game is called Battle Sheep, and they had all my sheep in one corner, and then I was trapped. So I was excited that they teamed up, and also the competitive side on me was a little bit like, come on, I can do better than that. So again, if you're looking for a fun game that's really accessible to littles too, it's called Battle Sheep. I absolutely love it. It's through Blue and Orange Games. They always do great stuff. So, what else is everyone up to? I see.
While we're waiting, which ones does your daughter have? Now I'm curious.
I don't know how to describe it. It's like a rainbow zebra unicorn thing.
Oh, I know which one you're talking about.
I
You
mean,
don't go to Costco because they have brought in a new like set right now, and I'm trying not to go in because I don't need every one of them. I don't.
oh yes, those little stuffed animals are something else. I'm waiting for them to come out with the body pillow version because I feel like that would be really comfortable. I don't know why they haven't yet. $1 million idea, right? So Lisa, do you want to tell us about your pyramid experiment?
Every year we do this. We when we start volume of pyramids and volume of cubes, etc., we always find our little pyramids, fill with water, and I let the kids estimate how many pyramids it's going to take to fill the cube. And it's so funny to hear these kids do it. And after we do they'll write it down. After the first one, they'll say, anybody want to change their estimate? And yesterday I had 2 pyramids of water in the cube. It takes 3. And one of the girls said, yes, I want to go from 2 just to 1/2. And I'm like, oh my goodness, because it takes 3. And maybe she meant another half of a pyramid. I don't know. But it's always fun to see what 7th graders come up with.
Oh, I love that one. I think we used to do it with rice, and then of course we would get like 10,000 pieces of rice on the floor afterwards. Sand, I only did once in my entire teaching career. I'll never bring sand back in my classroom again. Although that kinetic sand might be kind of neat. And then Lisa, do you all do? I think it might be called a slant pyramid when like There's a right angle to the base at the bottom, and it's almost like that pyramid just got kind of like slid over.
The eighth graders do that, but the seventh graders don't. And I primarily do this with seventh grade. But I did order a set of those last year with Gear Up money that's got like a string that hangs down the middle, and you can slide it over so it's on the slant, or you can see that it's the vertical height.
Oh, very cool. I see we got some other folks who are going to be joining us soon. They are yeah, uploading Zoom. I'll put a little message here. No problem. And Lisa, have you ever done the oranges and the orange peel before?
No, I haven't. I've seen pictures of it done, but have you done it? I'm sure.
I've done it in some classes and when we went virtual. So those of you who aren't sure what we're talking about, the surface area of a sphere can be really accurately estimated by peeling an orange. And so what you do is you put the orange down and you draw a circle around the orange, like as tight of a circle as you can. Then you unpeel it and you see how many times that circle can get covered using the peel, and it comes out really close to the formula unless you use cuties or those like little super sweet easy to peel mandarin oranges, because people can put a line around it, open it up, have like two halves and be like, oh, the answer's two, and that totally messed with my lesson. So the type of sphere you have and the thickness of the skin makes a big difference.
I may try that this year though.
Yeah.
But we'll use the cuties, and I tell them they have to make small pieces. They get to eat the insides.
We had one person too that would put the cutie on its side, and so she was like, well, I'm gonna do kind of three ways I see the circle. I've got like the circle that goes around almost like its waist, and then it turned out on its side and it was more of like an ovally thing, and then she did one more and she was like, because on average it's probably between one of these, and then her formula came out pretty accurate. These were math specialists in a college class that was kind of doing that, just to give you some context, but it was pretty cool. Laura, this is so cool. Tell us about using Mathagon for balances.
Buenos dias. Good morning. So I got that idea from when David did Mathagon a couple weeks ago. I hadn't really played around with that tool. It kind of felt a little intimidating to me, but 2 weeks ago he kind of talked about the balances and we went through it together. And that just coincided. In fourth grade, we have to teach them the idea of inequality and what that looks like. And it's not a very interactive way to teach it in the past. Like I haven't done it very interactively, but I used the Mathagon balances and my kids adored it. Like they would not want to stop. I taught them how to download the image and then drop the picture onto their slide so they can submit it for their homework. And they just kept playing and playing. They loved it.
That is so cool. Thanks for sharing. If you happen to have any of the like the templates that you push out to students, if you have them and you want to link them, I know my son's in fourth grade and their teacher is always looking for interactive things, especially if kids have to be home quarantined. So if you'd like to share them, I will definitely send them her way also. All right, folks. Well, welcome. Let's jump into our routine. We're going to do a notice and wonder, but with using animated GIFs. I really am on the whole GIF bandwagon. And so we'll just take a moment. There's slide 7 and slide 8. Now, I have picked these for very purposeful reasons leading up into the lesson, but you can notice and you can wonder anything about it. Just put your thought in one of those little bubbles. You can also make yourself some more bubbles if you want. But on slide 7 and 8, go ahead and tell us, like, what do you notice and what do you wonder about those? These are fantastic noticings and wonderings. As you are listening, feel free to keep typing more. There's many questions we could ask about it. I'm curious on slide 7, the person who put, I wonder how many handprints there are in total. 5 fingers times number of handprints. What were some of the things that led you to think about this question?
Buenos dias, Teresa, that was me. So of course I think because I live in 4th grade land and everything is early multiplication in 4th grade, I just was thinking like, well, you know, how could I turn this into a 4th grade problem, thinking about like 5 fingers on a hand, and he just seems to really be patting that paper many, many times. I wonder how many times he's patted it and how many handprints he's made.
Very cool. Noticing someone else noticed the one hand also. I'm also curious, somebody had written here, I'll highlight it in blue so you know I'm talking about you, painting over the same section of the paper and not covering the whole area. What led you to kind of wonder this?
Hi, Teresa, it's Kathy. I guess I was thinking that, you know, I wonder whether a child would continue if they had more time, if we saw more of this video, whether the child would end up covering the whole paper or whether they would be just satisfied in that one centerpiece.
Awesome. And if there was, so chat box here, if you have ideas, throw them in. If this kiddo were to be in, let's say, upper elementary mathematics, and we were in our geometry unit, what words might we use to describe, you know, what this child is doing? There's at least 5 words I could think of off the top of my head. What words do you think could come up in conversation as you're talking about this? Definitely seeing a lot of geometry terms: length, width, area, perimeter, surface area, square units, quadrant. Indeed, so now that we have a context for this, just asking students, you know, instead of saying like, here's all the vocabulary you need to know, like, let's check some prior knowledge. Here's some words. Can you describe on this GIF what these words mean? And it's a great way of kind of checking for prior knowledge, and they have fun doing it. Let's check out on slide 8. Somebody mentioned in blue here if it stopped, and that's one of my favorite things about GIFs is students always want it to stop. If that was you, tell us about the cube that you noticed.
Hi, Teresa. I think this is me. Yeah, I was just trying to figure out some of the mathematics around it, and the only way that I could do that was imagining that if all the pieces stopped and came together, and then I could visualize it as sort of one whole. I did see the symmetry of it, but I really needed to think of what would it be when it started before it started to move as well.
Oh, very cool. A fun fact, if you ever do want to stop these for your classes, doing a screenshot where it lets you start to do the snippet will freeze it for you. So you can kind of freeze it at your own time and make copy and pastings. I always like to encourage other people to do that instead of me doing it. But let's also hear from the person who came up with a lot of vocabulary terms that they could use. If this was you here in the blue outline, tell us what you were noticing.
I'm noticing volume, and if these are cubic units and how many go together to make a large cube from the small cubes, surface areas. But I was also looking at the colors as it explodes. The interfaces are also colored, and like how many of those interfaces would be the same color and so on.
So, and you can see I just froze it there. So the inner piece is like when they go in, it's almost like they're wasting their money coloring them if this was an actual Rubik's Cube. And there is a task, I want to say it's through CPM, called Colored Cubes. And it's all about middle schoolers exploring how many faces of these little individual cubes have colors on them, have different colors, and so on. So great for going into that. I also think that there's one cube that should be moving and it stays still and it's really annoying me, which is why I kind of put this on here. So all right, so we've got some prior knowledge into some vocabulary terms and some context to go with them. And that'll lead us into our math task. But before we start, I always start with our problem-solving oath. As I read it aloud, read it to yourself. And if you want to take the oath today, put your name in the chat. I, Teresa, promise to try my best. I will make sense of patterns and numbers. I will use manipulatives and drawings. I will make mistakes. I will ask questions. I will listen to other ideas. I will stay engaged by always trying to find another solution or representation. I am a problem solver. I make the world a better place. And I see so many great problem solvers there. Wonderful. So let's take a look at our problem. Today is focusing on area perimeter ideas, but I don't know about you all. I love Chef Gordon Ramsay because if you've ever seen, he talks so kindly to children. And it's really neat to see the different attitudes that he can give out. But our task is on slide 12. And it says, Chef Gordon Ramsay has hired you to organize an exclusive charity benefit. He has heard that you're an expert in arranging tables, which is very necessary because he believes in one rule: no empty chairs. He's expecting about 50 people, but you should be prepared for unexpected guests and no-shows. You can use triangular tables, square tables, or hexagonal tables, but not a mix of shapes. Whatever you pick, you got to stick with. You can store extra chairs in the chair room, but he expects you to use all the tables that you ordered for the event. There's no room to store extra tables. And it looks really sad to see empty tables. So, how many tables do you order? To clarify a little bit more into this task, I usually read the book Spaghetti and Meatballs for All so that students can get a sense for when you push tables together, that you lose seats. When you pull them apart, you gain them. So slide 13 is the quick and easy version of that. So don't make him mad. Here's an example. He was expecting 12 people, but 12 didn't show up. So in a moment's notice, you can rearrange them. And you can still keep the 4 tables you chose, but now you could have 8 people, 10 people, or 14 people. So in your groups, think about the shapes. You got a big number of 50. There can be no-shows. There could be extras. You don't know. You just need to be ready at a moment's notice to change. And there are 5 virtual manipulatives to get you started on slide 14. If you have no other questions, I'm going to go ahead and create those breakout rooms now. Alrighty, they are set. If you don't have questions, head on in. If you do have questions, I am always here to support you. Just let me know.
Still, I think get 10 people, 2, 4, 6, 8, 10. Yes. So you could do the same thing with triangles. So I like said, okay, if I have 2 triangles, I know I could put 6 people, multiple of 3. Or if I took the 2 triangles and put those together, you can put 4. So then I started looking, let me draw 3, just like in a long line. So I'm thinking first separate and then long lines. And I know you can turn those into a hexagon, obviously.
Yeah. So
Well,
I think I got what you're saying. Like, I think, can you check slide 15 though to see if I captured that?
yes,
That we're
but
saying like we
yeah.
have the multiple and then to turn it into a hexagon?
But
Oh, yeah.
if you did that, you could have 6 tables and you could see up to 18 people at those 6 tables. Or if you only had 6 show up, you would be okay.
Okay.
And then if you look at the top half of that, it's sort of like a trapezoid.
Mm-hmm.
Yeah, 1, 2, 3, 4. Wait, 1, 2, 3, 5. Oh, you can get 5 that way.
Right, because we're looking for those multiples.
Right. So I'm almost thinking that the triangle is going to give us the most different ways to do this with people.
Because with the triangle, we can hit even and odd.
Right. And we may not hit every odd, but like the square tables, I don't think you can ever hit odd numbers.
Right. Because you would only ever have groupings of 2, 4.
Right.
So then I'll have 4,
It's
5,
even from
6.
here on. Okay, so let me see. I'm trying to think here also. So if we did that, so like even what you've got there, if we split that, that's like 10 people that can be seated. If we split the top and bottom half. So it's like now we start making, if we look at slide 16, how those people are doing like their little,
I doubled 32, that's 64. That's too much. So whatever.
But if we put 2 of them together, we'd get rid of a 2.
That's true. Okay.
Hi, Teresa.
Hi, I just heard something. I want to capture it before we lose it, and I'll move it out of your way so you can keep typing. If we move 2 together, we get rid of 2.
4, I think, right?
Oh, no, you get rid of 4. You're right.
Yeah.
Yeah, because where it can't smash your right, you would get rid of 4.
Cool. So why did you change your mind on that?
Because
So-
when you smash them together, then it's 2 and 2 is 4. I was just looking at, because where's the other 2
1,
going to
2,
sit?
2, 1, 6, 8, 10, 12. Okay, wait, how many do we have? 6, 16,
My brain just looked at it funny.
32,
Well, it's
34,
interesting because
36.
you all are putting 2 seats at an end, and I think some of the other groups are mostly working with this idea of 1 seat per an end. What you stated is what would be correct if you were to communicate it with somebody else. And so that's one of the biggest parts about this task is the communication. Everyone kind of tackles it differently, and you got to figure out how to use words and context to communicate instead of just numbers. So that's one of the reasons I wanted to capture that.
Can we use this? No. Because then we would need a different table because now we have 44 chairs. 1 more of our traditional table would be
8 is 48. Oh, that's right. Okay, but then would you have too many? 1, 2, 3.
I have too
4,
many.
5, 6, 7. You have too many and I have too. Okay, but we can have too many people if they show up, right?
Right. So let's get something that has 50 to start, and then, well, let's.
Okay, so what do I have? I have 6. I have 8 times 6 plus, what do I have on mine? Plus 4. Right? I have 52. I think that's what I
Yeah.
have. Right?
Yeah,
8
I've
parts
got
of 6 and then that 1. Okay, what do you have?
I've got 54.
All right, because you got your single triangles.
Yeah, because you glued 2 triangles
Yeah.
together.
Yeah.
And it helps to think about the glues instead of just counting up the outsides. Sometimes I've found.
Okay.
And let's see. I'm going to try and make an arrangement that just has exactly 50.
Okay, I'm going to change my colors on my poly pad.
Hi,
Should I try and do some with a little less? Sorry, Teresa, were you there? Were you
Hi,
saying
yeah,
something?
I was just going to say, if you're going to go and try to make ones that make exactly 50, or Kathy, you mentioned some that are a little less, remember that we can't hide tables. So we're stuck with like however many tables you choose. You're going to be kind of stuck with that many. So can you make different arrangements to allow for less people and more people?
So we need to decide on the final number of tables and then go from there? Is that what
Or
you're
you
saying?
can keep altering it, but at the very end of the task, kind of come up with a number. This is the best number of tables.
Oh, okay, so optimize.
Yep.
Okay. Okay. So Gail, my gut.
Let's just find tables that work.
Yes. So then
Yeah.
even if anyone comes in extra, we can just split a table up from here.
I think so.
So if I do, hold on, I'm going to capture all of this. So then if I do this, right? Because then I've got, so let me get rid of these down here, or I'll move them off to the side so they're out of the way. So then if I'm going to make 5 copies of this, then I'll get that 50. Because if I do it this way, I've got 5 people at a
Now
configuration.
we've got 15. We've got 20. 25 people. I like our tables. I'm so glad you're good at this, Laura.
Oh, it's because we spend, like, with my 4th graders, we spend all our time on Google Slides.
I love how you're doing this group. Not only are you considering optimizing, chairs and tables, but just the literal layout here, you kind of optimizing the space as well.
Yeah, it's pretty organized.
It is. I'm going to move my little quotes. I'm keeping these for the discussion, things that I kind of heard, but you can move them like out of the way so you can use up all your space. I don't want to steal your space.
Oh, So if we're thinking somebody, like if we have like a no-show or then somebody show up, we could easily just take the chair away and it wouldn't affect the table configuration, right? Because the goal is to not have leftover tables.
Well, look on the bottom right, Laura.
Mm-hmm.
That last one table that's served by itself. So if only 49 people showed up, if we took away table 3, then one of those people could sit on the edge of table 2, so we would be down to 49 people
Yeah.
Yes.
with one less table.
Ah, there
But
is the
the
part of the
task-
problem that is trying to make it
Yes.
tricky for you. You can't store any tables. Whatever you decide on your tables, you're stuck with for the entire event. But you can eliminate or bring in more chairs. We have a chair room. So how can you optimize this so that whatever you decide for the tables works for 49, 48, 47, but also 52, 53, 54, and so on?
Like, how many do we need
How
to
about
go
we
over?
join? How about we join 2 tables together, the hexagon that we created before? So
Right.
that means
So yeah, I like that, Rowana. So like, for example, here in the bottom right corner, if I take, like, say these 2 people are no-shows, right?
yes,
And these people decide not, they don't want to eat delicious food. And I slide and I remove this as well. And then all I have to do is slide this section over.
you can't remove. They cannot. You
Hey,
can't
now
Oh,
remove-
that's right. I can't have, that's right.
51.
You can't have
Now you've
leftover
got
tables.
51. Make another slide and just copy this whole thing.
Yes,
and then
actually,
make-
let's duplicate and show the different options we can do.
Well, or we just changed. That's true.
Right. You can, I mean, it's like, and like when you start getting those
Okay.
strings, like that is 1, 2, 3, 4, 5, 6, 7. When you start stringing the tables like that in triangles, you always have 2 more people than you have tables. So now we have 5 tables in that little picture. Now you've got 1, 2, 3, 4, 5, 6. So that could be 8 people. So when you have strings, it's always 2 more people than how many tables are in the string.
Yeah. But I mean,
We're still at 48.
Then we've come back to 52 again.
Hi, group. Tell me about this 48 and 52 thing.
Well, because if you have the 48 and then you add another table of 4, it's 52. But then if you smash them together, then you lose a 2. But then the math just didn't work out, I don't think.
Mm-hmm.
If that makes
I
sense.
think because we're doing multiples of 4.
That made the 10 that we needed.
Oh, there we go. 2, 4, 6, 8, 10.
Okay.
The bottom right, because then you can just make 4 more of those.
Yes. And then we can,
10.
because the whole point is we can have extras for later, but he doesn't want any empty. So this works-ish.
So how many people do you have in this setup?
Too many right now. I got to figure out.
Oh, cool. Yeah, we want some for too many,
Oh, we do. Oh, okay.
right? Like you could have no shows. I mean, he knows the way party planning works. Whatever you think you're getting, that exact number will actually not happen.
Oh, okay. I thought we had to have exactly 50. I was.
Wait, don't, 40, 41, 42, 43, 44, 45, 46,
16,
47, 48, 49,
40. Yeah, that
50.
works.
Yeah, we have 50.
We have 50.
Yeah.
50. Yeah, the 4 on top, 4 on bottom, and then the 2 sides.
Yes. We have 50. But if we wanted to separate, we could separate for more people. Whoa.
Right, because you could just have extra chairs.
Right.
So I duplicated your slide for you. You might even do it a couple times and see, do your tables work out for things that are more than 50 and also less than 50? Like, could you convince me that buying this many square tables is the best number to use?
So I think more than 50 definitely works. We know that because we tried doing it. But
You can
less
take apart
than
the 4s.
50,
We can seat 6 extra.
yes.
Just the setup right now. We can seat 6 extra.
And then if we have one of less, I should call
So let's see, on slide number 21, what I did was I just annotated what we were thinking,
Okay.
right? So see on slide 21, we decided to try 30 tables and see how many people we could seat. So we can put down how many we seated there and what you have on slide 22.
Right.
30 tables, 50. So you got 50. Okay, so on here, on this one, I just have to think 4 times 15, that's 60 people.
Right.
Okay, so I'm going to write down 60 for this guy.
Why don't you put that picture down on slide 22? Because that's our 30 table slide.
Yeah, I will. Okay, I've got it off there and there.
So we've got a couple of pictures with 30 tables. We've got 50 seats, and we can put together.
And this is actually 60 seats, right, Gail? Because there's 4 that can sit at a table times 15.
Yes. So we can have
15
more,
times 4.
and we can also shove tables together easily for fewer people.
Yeah. Okay, how many did we, I'm going to go back to 21. How many people did we seat here? We had 1, 2, 3, 4, 5. Second times 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's our 10 times 5. So there's 50 there too. Okay.
Yes, I was trying to do 50 exactly.
So we're kind of, okay. And the one that you made on 22 was sort of the random mix. You said that's 50 people?
1, 2, 3, 4, 5, 6, 7, 8, 9.
You're running at 12:42. Okay, 10:42.
Right.
We got 2 minutes. Teresa, how do you do that, by the way? Is she there?
Yeah, it's super.
Do you have to go to each slide and paste it on, or is there an
It's
automated
super old
thing?
school. I go to one slide, I put it like where I want it to be, and then I just paste.
Oh, but you have to go to each slide that we're working.
So far, I haven't found a trick. I know that Alice Keeler has a trick, but I think you have to download some extra Google slide thingy.
Yeah, or you program it a bit with her stuff.
Yeah.
Okay. Okay, thanks. Okay, so how...
I like your music, Teresa.
Thank you. I really enjoy the jazz background stuff, mostly because it's a lot of music hurts my ears. I have hyperacusis and sound is always an issue, but that's gentle.
Hyperacusis. Huh? I think I have a kid who grinds his teeth all day in my room, and I'm having a really hard time because I don't know what that. Maybe I'm hyperacusis too, but noises.
Oh yeah, it's a whole thing. It was. I also work a lot with the deaf community, and when I hear, sometimes they'll say, "Oh yeah, I just turn off." I'm like, "Oh, that," and the way they describe it as being like, "Oh well, this it's too much sound. I just want to turn it off." And I'm like, "That sounds so lovely," but I hear sounds louder than most people do on a regular basis. So, yeah.
I'm gonna have to look into that because that's totally me.
Well, if that is unfortunate for you, then I definitely have some tips to share your way. But
Well, thank you.
yeah. All right, folks. So here we are. We're going to start on with group 2 on slides 18 and 19. They were the only group that really focused on the idea of using square tables. And square tables are super accessible. They're also the highlight in the story. If you read Spaghetti and Meatballs for All, it's a Marilyn Burns book about sliding tables apart and together. But what I wanted to focus on with this group is on slide 18, they have 4 tables together. And on slide 19, they have 5 tables together. What did you notice about scooting them together and apart?
So we started off with rectangular and it didn't work out. So we were trying to maximize as many seats as we could. So on slide 18 is when we have exactly 50. And then Teresa came into the room and she was saying, prove the fact that buying this many tables will be cost effective and would have more accessibility later. So on slide 19, we went ahead and we took another table and squished them into a longer table. So it gave us 48. So now we're trying to prove like, hey, this is a great number of tables to buy because you can make them you can seat more people if you separate them, but if you start putting them together, you can seat less people.
Very cool. So it makes me wonder, and I'm on slide 19, if I were to scoot another table in, what would happen to that 48? You can respond over mic, you can put in the chat. If I were to scoot these together, what would that new number be? I'm going to get close but not do it. Cool. So it would go down by 2. It'd be 46. What if I took another table and scooted that one down? Which leads me to my big question that I want to ask. If we did this method of only making the super long snake, what's the fewest number of people we can sit? And here, I mean, we could go down this tangent. Is there anyone who used like algebraic reasoning equations or expressions to solve that? If you did, I'd be curious if you what you did. I think a lot of us maybe just kind of did subtract 2, subtract 2, subtract 2. Anyone share? So Lisa.
Teresa,
I did what Lisa did, so I'll let Lisa share, but that's what I was doing. I was skip counting by 2s.
I didn't do it on a table, but I've seen this problem done before on a table and using algebraic expressions, but I didn't do it today. So every time we added one table, we lost 2 seats. We lost 2 total seats because the 2 ends that went together got lost.
Okay, so the 2 ends that got together got lost. So there gets to be some really neat algebra in here. With all the middle tables, they share something in common. The two end tables share something in common. And so we do have like this skip counting by 2 for all those middle ones, but the end tables have 3 on them. So it's almost like you have to plus 2 groups of 3 or plus a 6 after you have this. So if you happen to be, focusing on perimeter and area, we can talk about perimeter, but we can also start to think about equations and algebra. So I'm just going to let that simmer there for a minute and have us move up to slide 15 and 16. This group is working with triangles, and they had some neat statements. I'm going to bring them down on slide 15 that I captured when they were talking. But group, can you tell us why triangles?
So as we were getting started on thinking about which polygon shape we wanted, Lisa brought up the idea that a triangle would give us the most bang for our buck, because we would be able to capture multiples of 2, multiples of 3, 6, and we'd be able to hit the 50. We were worried that if we did a rectangle, we wouldn't be able to capture odd numbers. Or sorry, a square table.
Oh, were you able to get odd numbers of people?
I think we did. I think we didn't get a chance to capture it, but we said like if we had people show up, we'd be able to pull a triangle table off by itself, and then we could have 3 people sitting at a table.
So now we can get into that question about evens and odds. So earlier we had the algebraic expression that every table in the middle has 2, the end sides have 3. Now with the triangles, our end sides are different, our middle is different, but it kind of follows a similar algebraic problem. And then on slide 15, now they push them together to make a hexagon. So as you're looking through these, one of the things that I wanted to bring out, especially with area and perimeter, is that our area, whatever people are deciding is the number of tables, the area remains constant. And so why this is important, if you have students playing around with perimeter and area in their class, they might take out 30 triangles and they might try to maximize perimeter and minimize perimeter. The important practice that's happening is they are starting to count by 2s, 3s, 5s in order to skip count to find that perimeter faster and develop patterns within them. Let's check out what group 3
Lisa, I was going to say one thing back, like if we took our top left table, that seats 5 people with 3 tables. If we pulled table number 3 off, then we'll have a rhombus that would have 4 people, and the triangle could have 3 to get us 7. So there are ways that you eventually get right odds. And then if we split all 3 tables, that would give us 9 people with those 3 little tables. But we didn't get to do that with bigger amounts.
But you convinced me there that if we have a table of 3, in other words, if we have an even plus an odd, that we can get an odd number.
Right.
Awesome.
Or if we have an odd number of odds as well.
And that's different from what the previous group did, because if the 2 end tables are 3 and 3, that actually makes that 6, and then all the middle tables are even. So if we did this snake method, we might be able to make generalizations about even numbers. Of course, if we didn't bring up what if you just combine them all into making some super square. That's got some more fun stuff to it. But group 3 started really playing around with different arrangements. Specifically, they have a lot of neat ones on slide 23. Group 3, can you tell us what you started thinking about in terms of all the possible seats?
Gail, that's you and me. Yeah, we started with hexagons thinking they'd be flexible, that we talked the same way as another group did about the flexibility with the triangles. We could have way more combinations. And so then we just thought, okay, well, if we can figure out how many are seated at each grouping of table, then we can start thinking of multiples of and combine numbers to get a total of around 50 or just below 50 or above 50. So that's sort of where we left off after a bit of false starts. Gail, would that be correct?
Yeah, we had very similar to group one with putting 3 tables together on our previous slide. And then we started, separating them, seeing how many seats at each type of table that we could put together. That didn't work. Undo that. I was trying to put in a picture. When you put all of them, I think, and group one said that 30 was the fewest number of guests you could have, but I think if you slide them even more together, you can get even fewer guests and seat fewer. I was trying to take a picture of that, but having troubles getting the picture.
Take your time getting the picture. I'll definitely kind of bring some discussion here. If you want to add it, you can. So in middle school, they definitely get into optimizing, in other words, can you smush all the pieces together to get the smallest perimeter? And what shape is that? And that leads them into high school geometry, where they're essentially doing the same thing, hence our discussion earlier about oranges. A sphere takes the least amount of surface area. So if it costs a lot for surface area, that's what you'd want. And here we can see, like, if you start to move these triangles together, it's decreasing the perimeter. There's other shapes that will do that. And so then this problem you can really enhance it. Especially so for elementary school. If each table were to cost $10, then does that change it? Because triangles are really nice. You can make any kind of set with it. But if it costs the same, you might be able to do table arrangements with squares in a more cost efficient way than you could triangles. And then, of course, they might come back and say, well, in the real world, maybe they aren't the same, but it might just be like triangle tables are 10, squares are 12, hexagons are 14. What's the better one? Because you can sit more people. And so if you're looking to extend this, especially for learners who need that extension while you're supporting maybe some learners who are just, trying to figure out the difference between area and perimeter, there's natural extensions that still lead the same conversation in the end. So it's not like, kids know, like, I'm in this group, or, you're all talking about the same task. There's another shape that a lot of people go right to. Did anyone try out the pentagon? So in Mathagon, if you go to the Polypad, and I'll go ahead and copy this in the chat. A lot of times when I give Polypad, because they have all of the extensions, kids are quick to realize that the pentagon can get to 50. And so they want to use this, and then it comes in, well, what if there's one less person? And they're like, oh, easy, we just push the tables together. But there's beautiful stuff that comes out of using the pentagons. And again, this will keep your learners interested and engaged. And one of the things that happens here is they don't tessellate. And so you got to figure out, like, what would Gordon Ramsay do in a situation of, now I've got this little star in the middle, and he might be completely happy with it, or he might get very upset about that. And so you can have conversations about tessellations and more with it. So folks, that's the top of the hour. I'm going to open it up if other people have other extensions with it. I also have on slide 27 some other ones coming up. We don't yet have themes for the November ones. If there's something you want to get into, let me know. We'll fill that up. And next week, I am actually going to my future nephew's baby shower. My brother and his wife are having a baby, and so I'm going there, so we won't have our MATHURDAYS. And I'm also super excited. I officially have the Redbubble shop up, so if you want a Problem Solving Oath sticker, I will send that to you for free, but if you want other swag, it's up there now, so there's the link. I know, right? So folks, it's been a pleasure. Let me know if you have other extensions to this activity, but hopefully it's something you can bring perimeter and area in context to your classroom.
Teresa, I gotta go, but thanks for making our dreams come true with all the merch we are probably going to buy and be broke for, but thank you.
Again, I have a bunch of stickers. I ordered those in a lot. So if you all want some, if you want them for other teachers in your school, let me know. I will send those to you happily. But yeah.
You ship to Canada, Teresa?
I do. Yep.
Okay. Well, I think I might be buying some Christmas presents for my team of 8.
Awesome.
Because this is October, right? So I have some time. It'll get through the border in time. I might just do that. Okay.
Kathy, I need to ask you a question. Your backdrop, what is that?
Oh, this is okay. So I think I told you my summer task. I like photography, so I'm trying to get better at it. My task was to go to different places in Edmonton to showcase our city. And we have a place called the Moutart Conservatory named after Mr. and Mrs. Moutart. And there are 4 pyramids that are different biodomes.
Okay.
For plants. This is the show pavilion. So you can see, I tried to capture it so you can see the other pyramid behind it.
Right. That's what I saw.
Yeah. Yeah. So in Edmonton, when it gets really cold, now I work in Celsius. So when it's -30 and -35 and -40, whatever that is in Fahrenheit, this is one of my places that I go to try to get some light and warmth.
Okay. I want to get a picture and show my students on Monday.
Yeah. So